Welcome to Cambridge Chemistry channel with Sarvatyandan. This is question number 2 of 9701 October November 14 question paper 3-4. Let's start. In question number 2, in this experiment you will determine the enthalpy change delta H for catalytic decomposition of hydrogen peroxide into water and oxygen. Fp3 is aqueous hydrogen peroxide, Fb5 is manganese peroxide, the catalyst for the decomposition. Method: read through the method before starting any practical work and prepare a table for your results in the space below. For the first experiment, support the plastic cup inside the 250 centimeter cube beaker. This is, for example, this is the beaker, 250 centimeter cube, and this is polystyrene cup. Use a measuring cylinder to transfer 40 centimeter cube of distilled water into the plastic cup. Use a measuring cylinder to add 10 centimeter cube of Fb3 into the plastic cup. Measure and record the initial temperature of the mixture. Add a heaped spatula of measure of Fb5 to the mixture in the plastic cup. This is Fb5 is manganese peroxide used as a catalyst. Stir constantly until the maximum temperature is reached and record this temperature. Calculate and record the temperature rise. If wash and wipe out your plastic cup and rinse the thermometers. Ready for the second experiment. For the second experiment, pour the plastic cup inside the 250 centimeter cube beaker again. Use a measuring cylinder to transfer now 30 centimeter cube of distilled water and 20 centimeter cube of Fb3 into the plastic cup. Again, add a heaped spatula of Fb5 as a catalyst to the mixture in the plastic cup. Stir constantly until the maximum temperature is reached and record this temperature. Calculate and record the temperature rise. Wash and wipe out your plastic cup and rinse the thermometer. Ready for the third experiment. Carry out the third experiment in a similar way. Transfer 20 centimeter cube of distilled water into the plastic cup. Add 30 centimeter cube of Fb3 into the plastic cup. Measure and record the initial temperature of the mixture. Add a heaped spatula measure of Fb5 to the mixture in the plastic cup. Record the maximum temperature, then calculate and record the temperature rise. For the fourth experiment, use 10 centimeter cube of distilled water and 40 centimeter cube of Fb3. Now use this table to record the initial temperature and all the data in these four experiments: volume of distilled water, then volume of Fb3, initial temperature, final temperature, and change in temperature. So experiment 1, 40 centimeter cube of distilled water and 10 centimeter cube of Fb3 is used. In experiment 2, 30 centimeter cube of distilled water and 20 centimeter cube of Fb3. And similarly in the experiment 3, 20 centimeter cube of distilled water and 30 centimeter cube of Fb3 is used. And in experiment 4, 10 centimeter cube of distilled water, 40 centimeter cube of Fb3 is used. Now initial temperature for experiment 1 is 20 degrees centigrade. Initial temperature of all these experiments are 20 degrees centigrade, and final temperature of experiment 1 is 25 degrees centigrade. For experiment 2 is 30 degrees centigrade. For experiment 3 is 35 degrees centigrade. For experiment 4 is 40 degrees centigrade. Now change in temperature is for experiment 1 is 5 degrees centigrade, and for experiment 2 10 degrees centigrade. For experiment 3 15 degrees centigrade, and for experiment 4 is 20 degrees centigrade. Now draw the graph accordingly, like temperature rise on y-axis and temperature volume is on x-axis. So 2 large scale is equal to 5 centimeter cube. So in this way this graph is obtained. Now calculations: use your graph to calculate the average temperature rise for each 1 centimeter cube of Fb3. Let's assume the slope is and we have approximately, so this is equal to 0.5 degree centigrade, because so this is y over, by calculating y over x, so y is 5 and x is 10 centimeter cube, so this is equal to 1.2 or equal to 0.5 degree centigrade. So calculate, so this is the rise in temperature, average rise in temperature for each volume. So this is 10 over 20, this is 15 over 30, and this is 20 over 40. So the answer is 0.5 degrees centigrade. Calculate the energy released for each 1 centimeter cube of Fe3 used. Assume that 4.2 joule are needed to raise the temperature of 1 degree centimeter cube. So number 2, energy released is, we know that Q is equal to mc delta T, where m is total volume of the mixture, that is 50 centimeter cube, or equal to volume is equal to mass, and this is specific heat capacity 4.2 and rising temperature 0.5. So this is equal to 105 joules. Now use your answer 1C5 to calculate the number of moles of hydrogen peroxide in 1 centimeter cube of Fe3. So we know that the density of H2O2 solution is approximately 1 gram per centimeter cube, and the concentration of Fe3 is needed for exact calculation, and you know that we are using 1C5 to calculate the number of moles of hydrogen peroxide. In 1C5, 12.5, 1.24 is mole per dm cube is the concentration we have calculated in question 1. So this is 1.24 mole per dm cube into volume is for 1 mole, this is equal to 1 centimeter cube. So 1 divided by 1000 is equal to number of moles of H2O2 is equal to 0.00124. Calculate the enthalpy change in kilojoule per mole for the reaction below. Q is equal to 105 joules, so it is equal to 0.105 kilojoules used in enthalpy change equation. Delta H is equal to minus Q over N, so Q is equal to 0.105 divided by mole is 0.00124. The answer is 84.7 kilojoule per mole. Which one of the 4 experiments that you carried out is likely to be the least accurate? First experiment was it has the smallest temperature rise and greatest percent error, so greatest heat loss is in the experiment 1. So experiment 1 is least accurate. So this is the question number 3 of the same paper. You know that this is the qualitative analysis to identify the cations and anions, given cations and anions. You know we have different types of solutions. You will carry out the further experiment with aqueous hydrogen peroxide, which is used in question number 1. Fb2 is dilute sulfuric acid, Fe3 is aqueous hydrogen peroxide, Fb6 is solution containing 2 cations and 1 anion, and Fb7 is solution containing 1 cation and 1 anion. To a 1 cm depth of Fb6 in boiling tube, add aqueous sodium hydroxide until it is in excess. Then heat the tube gently and with care. Keep the mixture for test 2. Record your observation. Identify the cations in Fb6. Observation is green precipitates insoluble in excess. When mixture is heated, gas evolves which turns damp red litmus paper blue. It means ammonium ions and iron 2 ions are present in these Fb6. To mixture obtained from part 1 and add a 1 cm depth of Fb3, shake the tube, record your observation. Fb3 is hydrogen peroxide. Observation is green precipitates turns brown, so bubbles are formed. So this is, it means Fb3 is hydrogen peroxide, and we have F iron 2 in the FB6. So when these two reactions reactive, because when these two ions react with each other, with the when these Fe2 ions react with H2O2, this is a redox reaction, because hydrogen peroxide used as an oxidizing agent and iron 2 is uh, reducing agent. So bubbles of heat is produced during this reaction. Green precipitate turns brown when we shake Fb3 with Fb6 solutions. What type of reaction has taken place? This is redox reaction, as color change indicates, because green ions converted into iron 3 ions, so that's why green precipitate turns into yellow or red brown solution. So that's why it is redox reaction. To a 1 cm depth of Fe3 in a test tube, add an equal volume of dilute sulfuric acid Fe2, then add 1 cm depth of Fb7 followed by a few drops of a starch solution. Fb3 is hydrogen peroxide, FH2O2, this is H2SO4, then add 1 cm depth of Fb7. So Fb7 is a solution containing cation and 1 anions. The observations observation are yellow precipitate with Fb7 and turns blue black with starch solution. So it means Fb7 solution cations are unknown, while anion is iodide ion, because this is iodide ion test. Fb7, Fb8 and Fb9 are aqueous solutions, each containing 1 cation and 1 anion. Note that Fb7 was also used in A3. Fb7 is also used in A3. So add a 2 cm strip of magnesium ribbon. Fb7 was also used in A3. So no change with Fp2 fizzing pops with lighted supplant, and with Fb9 dark grey precipitates. Fb7 no reaction, Fb7 with and Fb9 pale yellow precipitates, Fb8 and Fb9 again white precipitates. Suggests the identity of cations in Fb9. So Fb9 is silver ion, explanation as yellow precipitates with Fb7, because Fb7 contain anion iodide. So this is ionic equation for this reaction. And from your observation, identify Fb8. Fb8 is hydrochloric acid, as with silver ion it gives white precipitates with silver ion, so that's why Fb8 is hydrochloric acid. So this is all about of this these two questions.